All right, so in this example, we're asked to determine how many zeros a function has by using the discriminant. And the function we're going to be looking at is f of x is equal to x squared minus 2x. So what the discriminant is it's equal to b squared minus 4ac. And if it's less than 0, that means you're going to have no real solutions as far as the function equaling 0. If it equals 0, then you're going to have one solution for this function equaling 0. And if it's greater than 0, you're going to have two solutions, two places at which this function equals 0. So let's go ahead and calculate the discriminant. Notice my a is 1, my b is negative 2, and it doesn't look like there is a c here. What's going on is we could say plus 0, and so my c is equal to 0. So if I plug these in, I'm going to have negative 2 squared minus 4 times 1 times 0. So negative 2 squared is 4. And then a bunch of numbers times 0, that's just 0. So our discriminant came out to be 4, which means there's going to be two solutions for this function equaling 0. So let's go ahead and graph this and see what it looks like. We've already done what the question's asked for, but we can sort of clarify what's going on. Well, I'm looking at the x squared minus 2x. I could do vertex formula, but what seems a lot simpler is that this has a common factor of x in both its terms. So I could just say that this function, f of x, is equal to x times x minus 2. Notice if you distribute this out, you get right back to what you started with. And so one of the zeros is when x equals 0, so I have a point right there. And the other one is when x equals 2. Notice if I plug in 2, 2 minus 2 would be 0. And so that's about there. Okay? Then just notice that this function, the highest degree term, the x squared, is positive. So this is a parabola that should be opening upward. So we're more interested in where the zeros are. So wherever this vertex is, just somewhere down here, the intersection points of the parabola are right there. That's where it equals 0. So that's just showing that while we use the discriminant to find the zeros of the function, we use the discriminant to find how many zeros of the function there are, that doesn't tell us what they are, and so we go back to the original function and we can check it with a graph. And so this makes sense. Notice also it would make sense if the function pointed downward, or if the graph went like this, there would still be two intersection points right here. And so that is finding how many zeros of a function there are using the discriminant.